Following up on my previous video, here is an additional video on the WizNet W5100s EVB Pico board from WizNet. On the GitHub page, you can clone the repository from WizNet's GitHub. I've already done that. You would need to run a create a directory called build or whatever you want. In this directory, you would need to run the command CMake -g Nmake make files. Once that has run, then you can run Nmake. Nmake on this particular repository would take over an hour to build, therefore I'm only going to build the specific parts that I'm looking at. So continuing, we now within the build directory go into the examples, HTTP server, then I run Nmake. While that is running, we're going to see code and show the area of the code that was blocking. Within the HTTP server, I'm echoing all the commands so that I can just see the progress. I don't have a debugger. This is the last command I normally get is print network information, and then I get the WizNet initialization call, which calls the W5100 SPI file. This is the area of the code that is getting blocked. So now that it's built, we get into the build directory, copy the UF2 file, and put the Pico into boot mode by holding the boot button and unpowering it and repowering it. Boot command, we can go to it, paste this in, and I use TerraTerm. It's persistent, so it stays connected all the time. Just connect to your Raspberry Pi and you should start to see serial outputs. If I disconnect the unit and boot it back up, there you will see the output. As you can see, the last command is the print network information. Looking back at the file, this is the last output before the unit runs WizNet initialize. If I now connect the Ethernet, it pulls up an IP address, and we're able to do an HTTP call to that IP address, local IP address. What I'm going to do now is block out that code and run it again. I blocked out the do command here and saved it. Control S. So we don't need to rerun CMake if we just change the files. So I can run Nmake again. The next thing you do is just copy the file over, which I've now done, and the unit is up and running. We go back into term. We should see it coming right up, and it goes straight into the network page, although there's no connection. To demonstrate that again, I just reboot it, and as you can see, the command here in 5 seconds starts running, and then it's open. So if I open up a browser and I go to that address, as you can see, there's nothing there. If I connect and then go to the address, I get a blank page, and over here I see the call coming through from there. So it seems to be working. I'll just do some refining on this code, remove the header, all the general header files, and just leave the specific header files that we need. The build file is only 90K, which is fine as long as I can keep it low. The Pi, I believe, has a 2 megabyte chip, so that's a 5% usage. I have a lot more functionality I have to incorporate. Next, I'll be doing Modbus, TCP, and reading the temperature, which is available from within the RP2040 chip, which can be read from the Raspberry Pi organization's documentation.